Today I'm presenting CoDeC, a system that generates realistic counterfactual explanations. This is CoDeC's interface. I'll start with the adult income dataset where we predict whether someone earns over $50,000 annually by loading its CSV file. Clicking Preview shows a sample of data tuples. I'll load the adult denial constraints text file. Clicking Preview shows the constraints loaded on the left, and on the right we have a constraints building module. In this scenario, Constraints 1 enforces that the education level must match its numeric code. Constraints 2 enforce executive managers to work at least 35 hours weekly. For a demonstration, let's input a profile of a recent college graduate who's currently working in sales in the private sector, but only about 18 hours per week. Our model predicts this individual will earn under $55,000 annually. The question is, what changes would lead the model to predict a higher salary? We'll allow education and work-related attributes to vary. These represent actionable changes someone could realistically make. However, we'll lock demographic attributes like age, race, sex, marital status, and native country, since they shouldn't factor into career recommendations. Now let's generate three counterfactuals. CoDeC first uses the DICE algorithm to generate diverse candidates. CoDeC projects DICE results since they may violate the constraints while minimizing distance and keeping diversity, ensuring adherence to the constraints. The projected results may now be negatively classified, so we may need to do the same process iteratively on those. At the top, we see a diversity score and an average distance, showing counterfactuals are both diverse and close to the original. Option 1 focuses on effort over education, staying in tech support but working 76 hours per week. Option 2 represents a different strategy, pursuing a doctorate with an education now of 16, working in tech support, a more sustainable 48 hours weekly. Option 3 offers obtaining a master's degree and transitioning to work at local government with only 25 hours per week. Now let's switch to DICE results. DICE suggests all doctorate degrees, but with critical violations. DICE 1 and 2 suggest education of only 10, while DICE 3 suggests 14. None match the 16 required for doctorate. Additionally, DICE 3 suggests executive manager occupation with only 25 hours per week, violating our constraint that requires executive managers to work at least 35. DICE results are clearly not achievable recommendation. Now I'll demonstrate a different scenario using the New York housing dataset. The task is to predict whether a property exceeds $1 million in value. For input instance, I would choose a real example from the dataset, a condo with 1 bedroom and 1 bathroom in Manhattan with 679 square feet, predicted to be valued under $1 million. House type, locality, and its sublocality will be immutable in this case and will generate three counterfactuals again. One constraint in this scenario states that for two houses of the same type, an increase in both bedrooms and bathrooms at the same time must lead to an increase in square footage. Larger homes need more space. Two other constraints limit bedrooms and bathrooms in Manhattan to at most 4. Here are our CoDeC results. We see that 3 different paths to reach $1 million valuation in Manhattan. Option 1 increases bathrooms to 3 with moderate square footage expansion, showing how adding rooms can boost value even in a compact space. Option 2 takes a different approach with 4 bedrooms and just 1 bathroom with around 2,000 square feet. Option 3 goes further, expanding even more than option 2. Together, these options demonstrates CoDeC's diversity. Now let's click Compare to show how CoDeC corrected DICE violations. For the first pair, DICE suggested keeping 1 bedroom and 1 bathroom, but simply expanding the square footage significantly. This violates the first constraint. For the same property type, you can't just increase square footage without adding more bedrooms or bathrooms. CoDeC fixes this by increasing bathrooms to 3 while slightly decreasing square footage, maintaining the relationship between size and rooms. CoDeC CF2 is similar to DICE CF2 since DICE instance already satisfies the constraints. In the third pair, DICE suggested 6 bedrooms and 3 bathrooms. This violates the constraints that limits Manhattan properties to at most 4 bedrooms. 6 bedrooms doesn't exist in Manhattan condos in our dataset. To summarize, CoDeC bridges the gap between flexibility and feasibility in counterfactual generation. By incorporating denial constraints, we ensure that counterfactuals are not just diverse, but actually achievable in the real world. Thank you for watching.